Welcome everyone to Labs Weekly number 3. Joined today with Dan and Adam and myself to talk about some security fun. And I guess we'll dig right in. There was something released just today or the day before about an auth0 JWT bypass, and I think Dan kind of wanted to dig into that a little bit and do maybe a little demo for everyone.
Yeah, I thought it'd be fun to talk about at least. So JSON web tokens are interesting, and I recently ran into them on some bug bounty stuff. And it was interesting to see this vulnerability disclosure today from Ben Knight, and I can show it. Basically, he found a bypass with JWT token authentication on auth0, which was cool. So the way that those tokens work is it's serialized JSON data. So you have like some JSON blob here, and then there's a signature, and there's a specific algorithm you can specify. There's many algorithms that are supported for JWT tokens. This is kind of a common one is HS256. So the vulnerability that he found basically was bypassing their detection of a none algorithm because their check was case sensitive. So if you provide some mixed camel casing of none as the algorithm type for the token, you can bypass the authentication. And typically because these are serialized, these public key cryptography, there's a lot of trust in the receipt of these tokens. So if I like using this site JWT.io to kind of pull apart tokens that you have and look at them. If you're building them, you can verify the signature on the tokens. You can change content in them. I also use for testing purposes. I sometimes will build them in Node.js. So I don't know. Have you guys run into JWT tokens? David, you said you used this burp plugin that I wanted to show off. That Ben said he used, the JSON Web Token Attacker.
Yeah. So JSON Web Tokens have been around for a few years now, and early on, a lot of the attacks were where you could replace the algorithm with none, right, and try and brute force your way in or whatever, utilizing that. JWT.io is great for viewing and, like you said, kind of creating things, but unfortunately, that site doesn't allow you really to create them with none. So I was looking around and I was like, hey, there's this burp plugin, and it's really straightforward. And I guess I'd never thought about trying to utilize some sort of capitalizing part of the word and whatever else for case sensitivity to try and bypass the checks for that, because it was such a common thing early on in JWT. So definitely an attack vector I've used before, just never thought about case sensitivity, I guess.
Yeah, and I haven't thought to test that either, which is interesting. Most of my use of JWT tokens has been to like validate stolen access keys that I've found in source repos and stuff like that, like commit histories. So I thought it would be cool to show the burp tool and walk through. So I have this this Node.js script that builds a JWT token for our good buddies at Zoom. Since I've been doing some testing on their APIs and stuff. So you can just ignore my secret key. I'm going to roll all that after this video. So for anybody that wants to try and type that out by hand, I'm going to kill it. But this just builds a JWT token that you could use with the Zoom API. So it goes ahead and makes a request. I have connection refused. So the way that I've been, I build it up with this Node script, and normally I pipe it through my burp proxy just so that I can get the full request. For some reason, I've had mixed success building them by hand, and I just wanted to use a example that they had on how to build up hitting the API. Um, so we'll just set a forward proxy real quick in burp so that I can use that to impersonate the real server and grab all of the requests. So I get the full token there, and we can see what the request looks like to the API. We just confirm that that's what it looks like here. Oh, so we have it as a bearer token. You can hit this API 2 ways. I did notice one thing that's strange about this plugin is sometimes it doesn't detect that you have a token if it's in bearer, as opposed to if it's in like a request parameter. So if you have the token in a request parameter, it's going to show you this JWS tab here. And then that will pull apart the token just the same as JWT IO will. So just to show that as an example, we can cut this and paste it over here and see all those same attributes. You know, here's my ID or my app ID that I've created with Zoom's API, which I'm gonna promptly delete after this video. But the algorithm type is HS256, and you know all that same content. So it does a good job pulling it apart. If you have a request you need to pull data out of that is in a bearer token or something like that, you can just copy and then go over to the Joseph tab and paste it into there. And it should have all the same data. So we send this over to repeater, we're going to see the same thing under the attacker tab. So we can load up signature exclusion. We can say, let's just set it to none, and that clicking update changes that token, and we send it through and it says invalid access token algorithm not supported, right? And I know that their API is not vulnerable. I tested that before this recording, but you would just go through and try all of these different methods to see if you get any hits. And in this case, we don't, but that's kind of the technique that you would use. I have not used the signature exclusion attacks. I mean, I'm sorry, I have not used the key confusion attacks at all. So I'm not familiar with those. David, I'm not sure if you are, because again, you said you've used this plugin before. I haven't. But
no, I've never really used it for the that sort of attack either. It's just the none signature type.
But to your point, it's great because you know JWT-IO and even trying to use some of the APIs like the Node API that I was using to make requests to the JSON Web Token library. They don't let you build malform tokens, so it's a convenient way if you've already got burp up and you're testing something to go ahead and start monkeying with the tokens to see if it works. So
this attack vector has been around since 2015. It's really popular in CTFs too. That's where I've experienced it. I've actually not used that add-on either, but you can actually do most of the decoding and everything in like just your browser console. If you open up like your Chrome console, you can do just some simple document.cookies and replace the auth and split it out into the algorithms and do all your decoding there if you want. And then even change and reformat and then just dropping it into a document.cookie, or you can use edit this cookie, which is another add-on. Like I said, this is a really popular CTF problem. The camel case or the case sensitive has not been something that I ran into either. So it's kind of interesting. It dropped in the last few days. One place that if you wanted to try this out yourself, I do know, and we're not affiliated with them at all, but I do know that Pen Tester Lab in their white badge they have a JWT lab if you want to go try it out yourself.
Yeah,
So
I don't know for sure, but I'm pretty sure Burp does too. Burp has a lot of labs. Could be wrong, but I think they might have something along those same lines. But so Dan, in the Joseph tool, did you have to add the camel case stuff to that signature request, or was that already part of it? I can't remember.
No, those attacks already came with it, and what I should also show is that it's not installed by default in inside of Burp. So what you'll need to do is go into Extender and go to the Burp App Store and find it down here in the JSON Web Token Attacker. But those attacks came baked in already. I'm curious how difficult it would be to extend this plugin and add some different like varieties of these. So like what happens if you just capitalize the E on the end? Like was somebody silly enough to, block these 3 varieties just because that's what came up in a test and they left the 4th variety, right? Sometimes it's just testing weird stuff like that ends up turning up cool vulnerabilities. And it's funny that I haven't messed with JWT tokens quite as much before, because I know a ton of other web frameworks that do their own custom signed cookies that don't use JWT. It's like their own signed JSON cookies that don't adhere to this standard.
one additional thing that I wanted to just bring up, I thought it was a funny coincidence. The person who discovered JWT critical vulnerabilities, I think his name was Tim McLean, and he created a guest blog on auth0.com in 2015, and it's funny now that now the vulnerability is on auth0. So, and we'll go ahead and link that in the description.
Yeah, that is kind of interesting and funny. But yeah, JWT has been around for a while, and it's utilized a lot for authentication. It's fairly easy. Most of the SSO type frameworks have it kind of built in as a standard mechanism to transfer auth credentials. But the none attack has been around a while. Just like I said, I've never seen it where camel case made a difference. So it's kind of cool. Awesome. One other thing I wanted to talk about today, since it was top of mind for us internally, we were getting some customers talking about IDOR, insecure direct object reference. So I thought we'd talk about that quick, and how that's a problem that has been something that's been really hard to I guess find and then solve for organizations for forever. It's an access control issue. So it's exactly as it sounds. Insecure direct object reference. Basically, say you browse to your bank and you want to download a statement, and you go to download that statement, and in that request, it passes a value of statement X, let's say. If I change that to statement Y, I shouldn't have access to statement Y. But with an insecure direct object reference vulnerability, there's no access control checking, and now maybe I'm able to download statement Y. And these have been fairly hard to not only find but fix, because it requires usually either some data layer access controls, so you have to have access controls in your data layer when you're making the database calls to say, hey, does Dave have access to Y when you're making that data request? Or there have been some other use cases where people will create like a parameter map or a hash map of Dave has access to these 10 statements, and I'm going to reference them 1 through 10 when he tries to download them, but in the code, in the backend, I actually map it to the real one. So I can't, or the user can't affect, the referenced object, if you will, in the database directly. And then, I don't know if Google works this way, but there are people who do things a little differently. Like maybe they'll encrypt the value of the token along with, something that's stored in that user's session, like their user ID or account ID or something that's not, that the user can't affect either. So that it's kind of a layer of access control. The problem with IDOR, outside of the fact that someone can access things they shouldn't, is finding them, right? You know, we have a lot of old systems, a lot of systems that have been written in ways where it's easy for users to look at a URL or look at a parameter and maybe change it from a 1 to a 2 and see what happens. And there's just been no tooling for it, right? You know, there's some tools. Burp even has the ability to do some sort of things. But at the end of the day, how do I know what Dave should have access to or what Dan should have access to with regard to whatever's being referenced, right? It's an interesting problem to try and fix. You know, I think, you know, I'm curious what you guys think too. You know, is this something that, you know, we think we could come up with a way to find more quickly with, you know, ML or AI or something to really learn an application and what's going on and what users are doing, because it's definitely a problem. I mean, I see it in bug bounties all of the time. Those issues that IDOR still exists.
Yeah, it's definitely something that can, as a malicious or a bad actor, you know, it's easy for them to test, right? Just changing a variable. I know when I was in college at UNO, one of my friends in our local hacking group called Nullify, he found a way that you could use IDOR to iterate over everybody's parking passes. And so he immediately went and wget every car, and then was telling us, like, you know, what our professors drove and stuff like that. And it's like, it's pretty easy to be a bad actor, but the business logic side of it is the tough part, like Dave said. I don't know if there's a good way for a tool to, there's certainly ways for tools to realize that if you can change parameters and return new data, that's easy enough to do. I don't know if there's a good way to know that if we're supposed to be able to do that, right? If you're looking at a document and the document is done by an ID, but like you change it and you look at a new document, like if you work for the company, like that's probably okay. You can look at all of the documents, you know, but like if you're a user and you're looking at your document, you shouldn't be able to then look at, you know, another person's document. So it's like that access control differs based on the user. So how do we know, you know, who's looking at this as a tool, right? I don't know if there's a good way as a tool without machine learning or AI, and I'm not even sure that's a good solution, to possibly know it without some sort of user follow-up or input. It's definitely an access control issue, business logic.
Yeah, even with ML, it's very difficult because the context is missing, right? And that's the thing that a human has to do. And all of the, you know, tooling that you can use to try to detect automatically this type of stuff is, I think the only options are really false positive prone, or at least very noisy. Now, what I do think is interesting and something that I would do, you know, on consulting engagements is, if you know that an application is built in such a way that it uses very strict patterns across the entire code base for authentication, authorization, etc., you can use some very specific linting and, you know, static analysis type stuff to build up, you know, an authentication or authorization matrix, and say, show me all of the functions that, you know, do not require authentication, or show me all of the functions that, you know, are accessible to, you know, a user with this role and accept parameters, and use that to help you target like manual review. But at the end of the day, the triage is something that that a human has to do. It doesn't matter what tool you use to do it, whether it's dynamic that says, oh, this page looks different than this page, and it was a number in the URL, or it was something that looks like an ID, and so we think that could be, you know, like Adam's example, you know, you're seeing a different report now, and we don't see anywhere that it's checked, because it's really hard to tell. You know, was that ID checked against a list that was in your session? Was it checked in another database call before it pulled the report? Like, all of those types of things can be really error prone, at least when you're trying to build a tool that is, you know, can be used across a wide volume of applications. The options are a lot better when you know exactly how the application is built, but that's the human element, right? The context that you need.
Yeah, I mean, access control in general is typically hard to test, right? And even if you have a really, really good like access control matrix, that doesn't really apply to IDOR, right? There's no real matrix here. It's like you either have access to that directly referenced object or you don't, right? There's like no give or take there, you know. You just think about all of the data that someone may request and the types of apps, you know, a lot of places that I look at, you know, if it's like a retail application, a lot of times like order IDs, right? Like order IDs for some reason are usually forcibly, I can browse to or change the value of that order ID and maybe even sometimes act on it. I mean, I remember a couple of times for clients or customers back in the day where I could just iterate over all order IDs and write a script and cancel every order in their system, right?
Sure.
And there'd be a huge impact. Now, maybe there's no like PII and critical data exposed, but if all of a sudden, you know, an Amazon or a Target or a Walmart or someone got attacked and all of their orders were canceled, you got to imagine that there's a major impact to their business right now, right?
Yeah, but you know, you can build that matrix and you use it to create a very highly targeted review. Like step one, we don't care about admin functionality at all. Like that can be tested absolute last. We care about anonymous functionality that accepts any type of like ID parameters. We really want to like hone in on what are these functions, like you said, view order. You know, that's part of the threat model when you're looking at an app, right? It's very important to me that somebody can't view somebody else's order. And that being a, you know, function that's available to the largest consumer base of that application, you know, that should be like top of your list on scenarios that you want to prove out in your testing. But from the tooling perspective, there's no context. If you're just hitting every single endpoint, every single URL, looking at every single controller from a, you know, SaaS perspective, or, you know, just spidering from a dynamic perspective, even in our scenario where we're using instrumentation, like there's, you know, we're looking at every request, and you could do some things to discern, like, you know, is there a string that's called admin in the URL? Is there something in the user's session that's, you know, admin related? But it's really kind of a guessing game unless you know exactly how that app is built.
Yeah, I mean, we hate always talking about Zoom, but you know, Zoom was under a little flack, you know, for something that's for the most part out of their control, right? People would record a video, that video would download to their machine, and then they'd go and upload that video to like an open S3 bucket or something to store it, right? But some malicious folks determined that those videos were named in such a way that they were predictable. So it's similar here, right? Like you can just change, oh, well, I know it's the date, I'm going to change it from 4/11/20 to 4/12/20, right? And maybe I can download other videos. You know, there's a lot of predictability to it. It's just been a problem that has existed forever, because a lot, I think it's hard to find with a tool. So cool. All right, guys. Well, thanks for everyone joining today. And next week, we'll have some more fun for you.
Code you hold, cause you know the 0-day heat will spray, clear the way. If the log file touch, get your hard line cut. Number 2, never let them know your next move. Don't you know bad boys moving silence and pirate taken from your wireless? I done flashed mad chips with these hacks just to patch these bits. Number 3, never trust nobody. IRC is bad.